see number 14 there. My recommendation whenever it's in kind of this form, especially as an early calculus student, is to rewrite it with exponents. So this is x to the negative 1/2 power. This first part, not the derivative, just rewriting it. Minus x and 3. This is really 1/3 x to the 3/5, but because it's going to go up top, it's going to be negative 3/5. Okay, so now you're ready to do your calculus, and this is the power rule. Okay, so it's your y prime. Bring that exponent down, negative 1/2 x. You're subtracting 1, so it becomes minus 3/2. The next one, this negative 3/5 multiplies the negative, so plus 3/5 x minus 3/5. I'm sorry, minus 1. Sorry, so minus 1 here, and that's how it depends how comfortable you are subtracting 1. So when you subtract 1, it's like subtracting 5/5 minus 8/5 there.
All right. And that's just the answer right there.
That's it. That's the final on that.
Alrighty.
Okay, 16 here. What do you see? What's the overarching or the biggest, like what's the main rule we're using here?
I see quotient rule.
Exactly. So if you need to, you can do this U over V, and there's absolutely nothing wrong with that. But it's better if you can do it kind of as you're writing it. So the derivative starts out, I'll write it over here, bottom times derivative of the top minus top times derivative of the bottom over the bottom.
I have a question real quick.
Of course.
Could you change this to by doing product rule by moving 1 plus cosine x up to the top and just making it all negative?
And it's not recommended in this case. There are a few cases. So like, let's say your instructor gave you like tangent x over e to the x. I would for sure tell you to go bring this up and make it e to the minus x times tangent x. But this is like a special case. What you said
wouldn't make it any easier.
No, what you said works, but makes it harder.
Okay.
This works and makes it better.
Okay. All right.
Okay. So we got to just, and your instructors, they're giving it to you. They're saying like, thou shall do quotient rule here. Like you will do it. That's what they're telling you here. So the bottom, derivative of the top, tangent x. So I sent you that thing yesterday. Again, just a reminder, would totally recommend that you memorize that. Minus the top, tangent x. And then what is the derivative of 1 plus cosine x?
It'd just be negative sine x.
Negative sine x, yeah. All over 1 plus cosine x squared.
That's final answer.
Yes.
Alrighty.
Is that okay?
Yes, that's okay. I understand that.
All right. Now 18 is good to do because it's weird. Let me make a comment about 15 though. We won't do it, but I want to make a comment unless you really think that we need to do it. This looks like quotient rule, but you can divide each of these by this to get 3 terms. Because it's really x to the 1/2 on the bottom. So it becomes x squared over x to the 1/2 minus x over x to the 1/2 plus 2 over x to the 1/2. And each of these you can reduce using, if you have x to the n over x to the m, it equals x to the n minus m. Do you want me to continue, or is that clear?
I understand that.
Okay. All right. So number 18. Number 18 is your first chain rule problem, something we talked about in a lot of detail yesterday. What is the outermost function or outermost thing that you see going on here?
I see square root is 7.
Yeah, and that's power rule to start. So your derivative is you bring this down, and what's uncomfortable here, and I use that word intentionally, is you're used to having a number here. So it is okay to write square root of 7 minus 1 as your exponent. Like it looks bad, it's ugly, but that is okay. That is totally okay.
All right.
All right. Now chain rule, the chain rule's coming over here to the right. What are we taking the derivative of now? Now that we've taken the derivative of the outside function, we're taking the derivative of
The inside
the
function.
inside function. Okay. And there could be many inside functions, but in this case, it's just x plus 1 over x squared. Why don't you tell me what to put here as the derivative of x plus 1 over x squared, please?
So could you move up the x squared up top?
Absolutely. So this is really x to the minus 2.
Okay.
And I like to actually rewrite it underneath.
Mhm.
Helps me visualize what it
But
is.
it'd be 1 minus 2 x
To what power?
to the -3.
Very good. Completely correct.
Could we do number 17?
Sure. You will for sure get questions on your test that just say, take the derivative of this thing. All right, now 17 is a product rule. I would argue if the instructor gave you this, I would tell them that I think you need kind of parentheses there just to
he
make
never
it clear.
does.
This is the break point.
Okay. That's what confuses me because there's no breakpoint.
Right. So sign requires an argument. Have you taken any programming classes yet? Or
No, sir.
maybe previous? Okay. It's the argument is the input. You can't leave it vacant. Like sign, you can never have the sign of nothing. There has to be something here.
Uh-huh.
So that's why it's, and I use this word, it's implied. I hate when things are implied, but it's the real world. The parentheses are implied. So it's like, you got to know they're there.
So the pi x, would that be the same thing? For example, I was like 2x.
Sure. Because it's a constant times x.
Okay.
So we're doing product rule here, uv. So it's I don't remember, we said it's u prime v plus vu prime, I think is the one you liked from yesterday.
Yes.
Okay, so what is the derivative of x squared?
2x.
Keep the second, sine pi x. Okay, let you get caught up here.
I'm here.
Great.
Good.
What is so you keep the first, x squared. What is the derivative of sine?
Cosine.
Cosine. You keep the inside part. This is chain rule though. That's chain rule because there's an inside part. It's not just x, it's pi x. D dx of a constant times x is always the constant. So it's just that thing in front of x.
That's fine. Okay. All right.
All right. So I'd like to do 20 as the final one before moving on.
Okay.
And actually, I'd rather have you try to talk me through this because it's a basic chain rule problem.
All right.
Like if you understand the chain rule, you can tell me what this is and do it as you go because there's only one outside and there's only one inside function here.
All right, I was just writing it down. All right, so first it'd be y prime equals cosine parentheses cosine x.
Okay, good. So that's done. Yep, times.
And then it'd just be negative sine x.
Very good. Done. These are much easier than the ones we were doing yesterday that you had sent me. Oh, and it's from Cengage. That's why Cengage is, I mean, they're kind of the standard on this stuff. Okay, what else would you like us to tackle? I see some, kind of story problems, related rate problems.
Yeah, let's do a couple related rates. That's kind of like the same thing as the implicit differentiation.
A bit, yeah, a little bit.
Just kind of grabbing it from the words.
Yeah, I'm going to do 67, even though it's odd because these aren't as straightforward as just here, take a derivative. Unless you need, well, let me just do this one first. So these all kind of have the same style, which is they generally give you some sort of geometric shape. In
Yeah,
this case, it's a cube. And it's expected, now cubes are pretty straightforward, but it's expected that you know the volume and areas of these things, which means I mean, you probably don't have time between now and the exam. You probably already know the answer anyway. If you're asking instructor, hey, are you going to give me the formulas? What's the instructor going to say?
yeah, he's gonna give us formulas.
Oh, good. Okay.
Yeah.
So volume of a cube is x cubed.
Uh-huh.
Okay. Now let's go ahead and read this. The volume of a cube is increasing at a rate of, you have to look at the units. The units tell you which letter it goes to. This is volume over time, and that means it's V prime. They're almost always all over time, so that's not what we're trying to figure out. We're trying to figure out like what is centimeters cubed, and that's volume. But you put a prime on there because it's a rate.
Uh-huh.
So V prime is 10. How fast is the surface area increasing when the length of an edge is 30 centimeters? So what is that? That's X. Now, is that an X prime? No,
No.
because it's not centimeters per minute or something.
Mhm.
Okay. All right. So now, great. Volume's great. Okay, wonderful. What is the surface area of a cube? So it's 6x squared. I'm just going to tell you that. You assume that's given. Okay, so how fast is the surface area increasing? So whenever you see the word increasing or decreasing, that is also referring to a rate, meaning the derivative. So what is the derivative of, this on the left? Sorry, right, this equation. So
12x.
SA 12x, but you told me it's x prime.
Mhm. Oh, yeah, yeah.
That's very critical. Okay. And this is a good problem because it actually, you're like, because you realize like, oh, I don't have everything. Do you know X? Yes.
Yes.
Here's X. Do you know X prime? No.
No.
So you have to get X prime from somewhere else.
Mhm.
So the only other equation you have over here is volume. So do you know the volume?
Yes. Wait, no.
No. You do know X, so that gives you the volume,
Mhm.
but we want X prime. So that doesn't help you here. So you have to take a derivative. So V prime is 3x squared times X prime. So do you know V prime?
We do.
Do you know X?
No.
Yes, right here.
Oh, yep, you're right.
It's the same. So X prime is the only unknown. Yay. Okay. Like think of this as like, remember when you were first learning systems, you needed X, you needed Y, you need
Mhm.
like here, you need two things because you can't get to X prime here. So you got to get it over here. So 10, that's V prime, equals 3 times 30 squared times X prime. Are you allowed to use a calculator on this exam?
No, sir.
Okay. All right. So 30 squared is 900 times 3 is 2,700. So you get 10 over 2,700. I would try to do as much of your homework as you can without a calculator because of that. So this is 1 over 270.
Yeah, we haven't used a calculator once this class.
Yeah, you don't need to. I mean, they taught calculus before calculators were invented. So, but that's a choice. Okay, so now you got X prime. You take this number, that's there, and you know X is 30.
Mhm.
And now you finally have it. So it's 12 times 30 times 1 over 270. That's 360. This is 360 over 270. The zeros cancel. 36 over 27, they're both divisible by 9, so it's 4/3. What are the units?
Centimeters cubed per minute.
Well, what's an area? What's a unit of area?
Oh, centimeters squared.
Per minute,
minute.
because it's the derivative. I would recommend strongly that you redo this problem on your own if you have time and not look at the work here. I'll try to send it out right away to you today because I know you're studying for exam. I would redo this on your own to see if you understand it.
Okay.
All right. The classic problem they're not showing here is the ladder. Did you have a ladder sliding
Yes.
problem? Okay.
Yeah, we've got a bunch of those.
That's like your classic question. I guess we'll do 68, although it's good. I think it might be more complicated, but we'll do that next.
Oh yeah, we've done like this, done one like this before too.
Great. Great. Paper cup has the shape of a cone with a height of 10 centimeters. So I like to actually start writing these things out. H equals 10. That's that right there. And radius at the top, that's good that they do. That's 3. Water is poured into the cup at a rate of 2 centimeters cubed per second. So based on the units, that's V prime. V prime is 2 because of the units there.
Mhm.
How fast is the water level rising when the water is 5 centimeters deep? So they're asking for H prime. How fast is the water level rising? That's H prime. When it's 5 centimeters deep at H equals 5. Is that okay?
Yes.
All right. So notice they don't give you the formula. So the volume of this is 1/3 pi r squared H. So notice you can find the volume from H and R, okay, if we need that, okay? But the volume is always that there, great. Okay, what are we trying to find? We're trying to find H prime. So we need to take the derivative of this, and you'll see a problem here shortly when we do this. So the derivative of this, let me rewrite it over here. So V prime is, and this is a product rule. Now, 1/3 pi is a constant, so I'm just going to keep those there. So we're really taking the derivative of r squared h.
Mhm.
That's like your u and your v. Did you see that in class?
I don't remember.
Okay, so if you need to, you can write off to the side here, but that's u and v. So your derivative of r squared is 2r r prime, right?
Mhm.
Our rule, but it's r prime. Keep the h plus r squared. Derivative of h is 1, h prime. So how many of these quantities do we have? Like, do we have V prime? Yes.
Yes.
See how we have V prime? Actually, that won't be clear. So let me switch colors here real quick. Do we know, sorry, let me slide up here. Do we know the value of R?
Yes.
What is the value of R?
3.
It is 3 at the top. Do we know the value of R when it's 5 centimeters deep?
Oh, I guess not.
We don't. Maybe we can find that though. Okay.
Mhm.
So we have that. That one's a question mark. Do we know R prime?
No.
Do not. Okay. We do know H. Yes, good with that.
Mhm.
I'm sorry, we know V prime. We do know H. We don't know R, and we're trying to find H prime. So lots of problems here. Do you agree with that?
Yes.
Okay. So at some point, your instructor probably said something to you like, you got to look at the cone as a triangle.
Yes.
So here's the height, and then here's R, and then you have to like make similar triangles. So it's like at some point here, your H up, right? And your
Mhm.
R up. So your H over R is proportional to what? And it's the real height of the cone, which is 10, and the radius at the top, which is
3.
3. So make this is really important. If you don't do this, you will never get this problem correct. So what I'm trying to show you is that like you can at any point besides the top that you have to describe the height in terms of h, but at the top it's got a height of 10. The radius down here at the bottom is 0, and then it's r, but all the way at the top it's 3. So you have to build this ratio.
Mhm.
Now, why is this important? Because you can solve for one of the variables. So let's go back and look at our volume equation. 1/3 pi r squared h. Are we ultimately interested in r or h? R prime or h, right? So we
Mhm.
need to solve for r because that'll get rid of the r here. If you say r equals something, 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 you're going to square it, multiply times h, and then you've got it. Is that clear?
Yes.
Okay. So to solve this for r, you can rearrange 3h equals 10r, r equals 3 over 10 times h. If this isn't clear, just figure out a way to remember it in case you get a problem like this on the exam. This won't come up again in your class. So this gets put in here. Volume is 1/3 pi 3 over 10h squared times h. So volume is equal to 1/3 pi, and then this is 9 over 100, h squared becomes, I'll just leave it like this, h, so it becomes h cubed. The 9 cancels with the 3, so your volume is 3 pi over 100 h cubed. So now when you take a derivative, it's only in one variable, and this is very critical here. Is there anything I've said so far that you would like me to clarify or run through again, or?
No,
Okay.
I'm getting there.
Great. V prime now, power rule. Like this is a constant, 3 pi over 100. Derivative of h cubed is 3h squared, h prime. And we want h prime because that's what we're trying to solve for. Okay. So a little bit of rearranging here. When something's in the bottom, it goes to the top. So it's 100 v prime over 3 pi. If it's in the top, it goes to the bottom. You've got this 3 here and this h squared. So that's going to come here, equals h prime. That's how you do these quickly, is if it's in the numerator, it goes to the bottom. If it's in, yeah, if it's in the denominator, it goes to the numerator.
Okay.
So you're solving for h prime, and you have all these values now. You have v prime is 2 over 3 pi times 3. H is 5 squared. Okay. And a lot of cancellations here. So 5 squared is 25.
Mhm.
So that goes in there, that becomes 4, and that goes away. And then you're left with 8 over 9 pi equals h prime. What are the units of height? Centimeters per second. You gotta have your units or you'll be deducted on these problems. Now I've avoided asking, but will you get problems like 66, these where they give you the function and they ask you to find like the derivative and then write an interpret statement of the derivative?
Yeah, he's done an example like that one before.
Okay. These particle motion problems like in 65 are pretty common. Where do you want us to go next? I guess is what I'm kind of trying to get you to tell me here.
Um,
Well, you can do more of these, but it's up to you.
Let's do. Let's do one. Let's do one like 38.
Okay. Let me get back to where I've got that one up.
It might be super simple. I just haven't seen one like that before.
No, it's not.
Okay.
Let's assume the instructions. I mean, I believe the instructions are find the derivative. Is that right? It's a continuation of the previous ones. Yeah. Okay. All right. Now, if you were to take the derivative of u over v, okay, what would you have to do when you take the derivative of the top or the bottom? What derivative rule would you be using for the top and the
Product rule.
That's bad, right?
Yes.
So when I stare at this, I think ahead. I say, oh, well, if I FOIL this, x squared minus 5x plus 4, do you have to use the product rule then when you're taking the derivative of it?
Not anymore.
Not anymore. So this is a case of when it's good to kind of look ahead. And I don't know how to tell you to do this because this is hard. It's very hard to do. Um, it's to know. It's like branching. It's like, well, if we go down that branch, I got to use product rule. I have to use quotient rule. Down this branch, we're still going to get to the same answer, but it's a little bit easier. Maybe it's a little wider, and then you come down here. But this is one of those where if you see this, it's much faster.
Okay.
So now it's just a U over V. Do you want to try it, or is that enough for understanding on this?
Let's just try to do it.
Okay. Why don't you take 60 seconds and try it on your own, and then I'll start filling in the answer here.
Okay. So the first thing I do when I take the derivative of each one up top,
Yes. So
and then start doing quotient rule.
Well, you're going to do, I'm sorry, it's the bottom, right? The bottom just comes up there times the derivative of the top. And the derivative of the top is
okay.
2x minus 5.
I understand. Okay.
Christopher, the keys are over here. Keys.
All right, I think I got it.
All right, great. So minus the top, x squared minus 5x plus 4 times the derivative of the bottom, which is 2x minus 5, all over the bottom squared.
All right, that's what I got.
Great. Look through those derivatives and see if there's any more there that are uncomfortable. You don't feel like you would know how to start, because starting is key on these things, taking a step in the right direction.
Let's do. Did we already do number 19?
We did not. 19 is a classic
Actually, yeah, never mind.
quotient rule problem. There's nothing else to simplify in there.
You're right.
There's a small variation I can make on the problem that would have some cancellations, but do you remember your first test with the instructor? Did you like from the review to the exam, like have you thought through like what was the same, what was different, like anything?
It was all pretty much like accurate.
Okay. There's always a tell with the instructors, what kind of questions they like, what do they emphasize. That's the kind of thing
they like to put stuff, or he likes to put stuff from quizzes and homework.
Okay.
On these, it's only like 10 questions.
Right. Like a problem like 32 that has a lambda in it. That's a Greek letter, or some from yesterday that seemed to have more symbols that were not variables. They were just constants. Is that a tendency of the instructor, or is it?
He doesn't have that one on the review.
Okay.
I mean, we've done them in class, but he hasn't put any on homework assignments. Hang on, let me tell him to be quiet real quick.
Sure.
All right, sorry about that.
No problem. I would recommend us looking at 65 because it's got some things about moving up, moving down, some things like
All
that.
right.
This is a classic problem you see in calculus. You also see it in physics if you end up taking that class, which I would assume you will. It always asks usually for the velocity acceleration functions. Velocity is the derivative of position. So y is position. And sometimes it's referred to as s. That's kind of the other one. But y prime is velocity.
And then y prime is acceleration, right?
Y double prime is acceleration, exactly. So you've got to be able to do this really quickly, like 3t squared minus 12 is the velocity. And then the derivative of this is 6t.
Okay.
Okay. Now, oftentimes this velocity one has 3 terms and you end up having to factor it. This one, not so much. Now, it doesn't ask it here, but I'm going to ask you, when does velocity equal 0? Or it might say, when is it not moving? And that's what velocity equals 0 means.
When is it not moving?
Yes, when is velocity equal 0? And that's the same. It means the same thing as if it says, when is the particle not moving?
When acceleration is equal to 0?
No, yes, but more generally, I'm asking you to set the velocity function.
Oh, when t is 0?
3t squared minus 12 equal to 0.
Uh-huh.
But it's worded this way. It would say like, A, when is velocity equal to 0? Or A, when is the particle not moving?
And then would you just solve for?
Yes, you
t?
solve
okay.
for t.
Right.
But I want you to do that here because I want you to see this. You end up getting t squared equals 4, t equals plus or minus the square root of 4, which is plus or minus 2. But can t be less than 0?
It says it up there, right?
It says it has to be greater than 0, greater than or equal to 0. So you have to know that because you can solve these problems and get an answer that isn't like reasonable because it can't be negative.
So that up there in the question, that tells you whether to use a positive or negative number.
Right.
Okay.
Now, time is almost always forward positive, but there's other situations where maybe that's not the case. Okay. Now, I can also ask you, when is acceleration equal to 0?
And then you just solve for.
You set 6t equal to 0. And that's when t equals 0. Was this emphasized much in class?
Yeah, it was a while ago though.
Okay.
It was like first week.
All right. I would recommend us doing some more derivative problems. If you cannot, if we have not done a implicit derivative, and those start 23, 20.
The ones I look at and are like comfortable with are 23 I'm comfortable with.
26.
26 I'm comfortable with.
Okay.
But we can still do it. 29.
29 is another one, yeah.
29 you use chain rule.
You do?
I'm pretty comfortable with that one.
Okay. Have you been studying during the day for this? If you had other time to look at stuff?
Yeah, yes.
Okay. I'm sensing more confidence in you than yesterday.
Definitely.
Yeah. All right, we got some time here. What
else? He's recommended I feel pretty comfortable with. Except the related rates one I'm still kind of iffy with.
Yeah. Let me go back and find the thing that you sent me from yesterday. Let me pull one up from there, because I think that'll be good for us to look at. Thought you had some questions on there. Yeah, okay. Let's look at, oh yeah, these are
Overall, I am more confident about all this stuff.
good. Yeah,
And
yeah.
for the rest of the day, night, I'm just gonna be practicing.
Okay. That's good. So the goal of this chapter is like you need to be able to take a derivative of anything you see anytime. The related rates aren't as important, but they are emphasized in the test. But and to do the rest of calculus, you need to be able to take the derivative of anything. And that's where you're at. Is this ship problem okay? Or would you like me to switch to
Yep, we can go for it.
Okay. Ship A is 150 kilometers west of ship B. Ship A is sailing east. Okay, so A is here. You didn't know, that's wrong. It didn't know, that's right. Sorry.
We've done one similar to this before.
Is this right?
This will probably end up
Yeah,
on
this
the
is
test, to be honest.
okay. Ship A is sailing east. They're going this way. Is that right? Is that
Yeah,
and
that's
ship
right.
B is sailing
It's
north?
kind of worded weird.
Yeah, these are all okay. How fast is the ship's wait, when did they start? We can't do this because I don't know when they started.
This is at noon.
Oh, at noon. Okay, there is the language in there. Okay, so we got to figure out what happens in 4 hours. 4 hours later. So they start and they're 150 apart. But in 4 hours, how far has A gone? They've gone 170.
Okay.
So their final position is over here. Well, let me draw it like this way. It's 20 here. So A is over here when they're done. This is 20. Do you agree with that?
Why is it 20?
They're 150 apart.
Oh, okay.
35 times 4 is 1. I'm sorry. Wow, this is bad. I'm sorry. It's 140. No, that's not correct. Okay, they're not 20. They're really sorry. This is bad. They're here and they're 10 away from where B started. So B started here and they're 10 away.
All right.
B has been going for 4 hours also, but they're only going 25 miles per hour. So they're up here at 100. So the at time 4 o'clock, this is 100 and this is 10.
Okay.
And this is really critical to get this final triangle settled. Okay.
So if you hadn't said that, I probably would have done this completely wrong and be like, make a right triangle before, like.
Yeah, I mean, it's a really good problem.
At noon.
This is what makes it really interesting is because they start further apart. Usually they start together and then they like two people walking away, but this is real life. Like ship's there, you're approaching another ship's moving away.
Yeah.
And you have to realize like, where are they actually at relative to one another at that time? And you said noon. I didn't catch that at first glance. So I like underlining and circling stuff. That'll definitely help. Okay. Now at noon, and you probably did this on the ladder problems. I like to draw arrows to show what the velocities are. So like y prime is 25.
Would those be those are the y prime.
And x prime is 35. Now, depending on which way you call positive or negative, x prime could be negative. And I actually would encourage you to assign it to be negative because right is almost always negative. I'm sorry. Forgive me. It's positive. Forgive me. Left is always negative. So because it's moving to the right, even though it's left of it, it's moving to the right, it's still positive. If it's moving to the right, it's positive. If it's moving up, it's positive. Okay. Like if the ladder's sliding down, that's negative. Or if the ladder's sliding towards the wall, which almost never happens, that's negative. Okay. We're asked for the distance between the ships and how fast is it changing. We're looking for D prime. Okay. So what equation governs the relationship between the triangle?
Diagram theorem.
Right. So it's x squared plus y squared, but then we use d squared. So we generally don't use a and b. X and y are preferred here. So each of these is implicit. So it's 2x, x prime plus 2y, y prime equals 2d, d prime.
Okay.
The twos all cancel. What are we solving for? What are we trying to find? What's the question asking for?
Looking for D prime.
D prime. So we got to solve for d prime. So d prime is x, x prime plus y, y prime over d. So do we know x? Yes. X is 10.
So you got that. Okay. You got that equation from moving the 2D over and then just factoring out the twos.
You can just, I like cancel them from the start.
Yeah. Okay. Okay. All right. I'm with you.
Okay. So do we know these numbers? Yes, we do. X is 10. It's moving at 35. Y is 100 and y prime is 25. That's how fast it's moving. Now, do we know D? Do we know the distance between the ships?
We do not.
We do not, but we can calculate it from this equation.
Uh-huh.
So D is equal to the square root of 10 squared plus 100 squared. Pythagorean theorem. So they don't give it to you, but you can calculate it. Sometimes in those volume questions, it's kind of the same deal. You don't know the volume, but they give you enough to find it. So that number goes from the bottom square root of 10 squared plus 100 squared. And that's it. You're done.
All right.
Did you have enough time on the last exam to finish everything?
Yes, I did.
Okay. This one may be enough. You may not need to simplify. Don't know. The bottom doesn't simplify. So your instructor is probably going to give you numbers that simplify well. So maybe remember some of your Pythagorean triples like 3, 4, 5,
Yeah.
5, 12, 13. And there's a few others, 8, 15, 17. So on. Any quick derivative problems we can do? Probably all we got time for. If you got another derivative, straight derivative we could look at.
Let me see. Did we do 15? I feel like we did.
We did 15. 15 is the one. Let me go back up to it and I'll just point out the step here. It's kind of like the question you asked me down the ways on number 38. In 15, you want to do the simplification first.
Oh yeah.
Okay. Because if you do quotient rule, you'll be marked off. And it's okay if you do that, but like the instructor's testing, like not just do you know how to use quotient rule, do you know when to use quotient rule? And that's the, I think you got a good instructor, although these problems you're getting are somewhat difficult, but like, do you, like, it's more than just doing, do you understand why you're doing it? That's the charge I guess I would have for you, is to like really not just, you do want to become a doer, a technician, but then do you understand why, why use quotient rule versus just simplifying first?
Yeah. Quick one. Let's do that was not on there.
We're cutting it really close here. I think this is a good place for us to stop.
Let's do 33.
33. Okay.
Yeah.
I'm going to run through it really quickly. And then I will get these notes to you. May not be until the next hour because but I'll do them for you by within an hour and 10 minutes here. All right. So here we go. This is product rule. There's your breakpoint. Derivative of square root of x. This is really x to the 1/2. So it's 1/2 x to the minus 1/2. Keep the second. And it's okay to mix exponents and roots. Plus, keep the first, square root of x. Derivative of cosine is minus sine. And it's okay to put parentheses to show multiplication. Keep the inside. But now we have to find the derivative of x to the 1/2 or square root of x. We actually already have it. And you'll see this when you're taking like second derivatives. Like, you don't need to reinvent the wheel here. Like, just put whatever it is if you did it already. Don't think too hard about it. You just basically just copy and pasting it over there. All right. Thanks so much for scheduling, Trenton. I do think you're going to do on this test. I would recommend some more studying, but give yourself some breaks. And I really appreciate you scheduling. So love to work with you again. And I'll
Yeah, I
send you the notes and
definitely
screen.
will.
Awesome. I'll send you the notes and screen recording out within about an hour and 10 minutes.
All right, I appreciate it.
Thank you. Bye now.
All right.